Okay, we're going to continue working with some natural logs, and we can solve these in the same way we solved other exponential equations by using the natural log if the equation has Euler's number as the base. Okay, because a lot of times this will show up, and we'll see that the base is E, Euler's number, 2.71 blah blah blah. So let's see how we can use the natural log to solve equations that have Euler's number in it. So we need to isolate the base, so the Euler's number. We need to write in natural log form, and then we need to solve it by using a calculator to round it to the nearest thousands. So we got 4 times e to the negative 2x minus 5 equals 3. Well, the first thing that we're going to do is we're going to get this e to the negative 2x by itself. We're going to get the base by itself. First thing I need to do that is add 5. So it gives me 4 times e to the negative 2x equals 8. I also need to get rid of that 4, so I will divide by 4, which is going to give me e to the negative 2x is equal to 2. Well, now I can write this in logarithm form. Oops. Because I'm looking at e to the negative 2x equals 2. So if I wrote this in logarithm form, this would be the natural log of 2 is equal to negative 2x. And now I can solve this for x just by dividing by negative 2. So I got the natural log of 2 divided by negative 2 equals x. All I have to do is evaluate this in a calculator, and it says round to the 10,000ths, so that's 4 decimal places, I believe. So let me get out my calculator. So the natural log, right here, ln, of 2 divided by negative 2. All right, so tenths, hundredths, thousandths, 10,000ths. So negative 0.3465. Negative 0.3465. That will be my solution to number 1. Number 2, we have 4e to the negative x plus 8 equals 17. So first we need to get the base by itself, which is the right here, the e. So we will subtract 8, which gives us 4e to the negative x equals 9. We'll divide by 4. Gives us e to the negative x equals 9 over 4. All right, now that we have the base by itself, we're going to write this in logarithm form. Okay, it's currently in exponential form. Is e to the negative x equals 9 over 4. So if exponential, this would be the natural log of 9 over 4 equals negative x. And now I don't want negative x, I want positive x, so I'll divide by -1. The natural log of 9 over 4 divided by -1 is equal to x. And I just have to plug this into a calculator to figure out what this is. So 9 over 4, natural log of that, and then divide that by -1. All right, so this is what we get. Round it to the 10,000th place, so negative 0.8109. 0.8109. And that will be our value for x here. That will be our solution. Now let's say that we want to solve a logarithmic formula or logarithmic equation where the variable is inside of a log. Well, very similar. We will just instead change it to an exponential and solve the corresponding exponential. So this is 3 times the natural log 4x equals 24. So first of all, we isolate the logarithm. So in this case, we got 3 multiplied on the outside, so we'll divide by 3 to get rid of that, because I'm trying to get the logarithm by itself. So it'll be the natural log of 4x equals 8. All right, and now I want to turn it into exponential form. So currently it's in log form, which means that the base is e of 4x equals 8. So rewriting this in exponential form would be e to the 8th power equals 4x. I can now solve this for x by dividing by 4. So e to the 8th power over 4 is equal to x. And I can now use a calculator to evaluate this, e to the 8th over 4. All right, so let's take a look at that. So we got e raised to the 8th power divided by 4 equals this. And we'll round it to the 10,000th place, so 3 decimals, or 4. So 745.2394. And that would be our solution here to this problem, number 3. Number 4, we have 5 times the natural log of x plus 6 is equal to 8. All right, so first we need to get that natural log, the logarithm by itself. So we'll divide by 5 to get rid of that 5. That's natural log of x plus 6 equals 8 over 5. That can't really be simplified. Now I will turn this into an exponential. So it's base e of x plus 6, 8 over 5. So as an exponential, this is e to the 8 over 5 power equals x plus 6. And I can very easily solve this for x by subtracting 6. So I have e to the 8/5 power minus 6 equals x. I can put this in a calculator and figure out the exact value. So e to the 5/8. So e raised to the 5/8 power. What else do I need to do? And then minus 6. So negative 4.1317. Negative 4.1317. And this would be my solution. And of course we could check this by plugging it in. We would have, so I'll just check this so we can see how we're supposed to check these. So 5 times the natural log of negative 4.1317 plus 6 equals 8. So that's 5 times the natural log of, add 6 to this, 1.8682. So I'll take the natural log of that number. Oops, I messed that up. 1.8682. And I'll multiply that by 5. And I thought something was up because I'm not getting the correct solution. So let me go back and let's see where I have made a mistake here. I think it probably had to do around here. So let's try doing this again. E to the 8/5 power. So E raised to the 8/5 power, 4.95. Yeah, I made a mistake there, and then subtract 6. Negative 1.0469. So let's try that. I think I might have put it in the calculator backwards. So this is 1.0469. And let's see if this works instead. So let me plug that in. And this is why you should always check your answers, because it's very possible that you made a very small mistake. Okay, so let me try this. 5 times the natural log of, add 6 to this, 4.9530. So 4.9530. I'll take the natural log of that. and then I'll multiply that by 5, and I should get 8. Yeah, I get 7.9999. Okay, so I did make a mistake, and I think I had put it into the calculator as e to the 5 over 8 instead of e to the 8 over 5, and I think that's where I made a mistake here. Um, it wasn't looking right to me, so I'm glad I checked it. So this is my actual solution, negative 1.0469. Okay, here are the problems for the assignment.